Welcome back to Coronavirus University and the third part of our discussion of the matrices for linear maps, in particular rotations or other symmetries in 3 dimensions. So we saw what the rotation matrix for rotation in the plane by an angle theta looked like. And suppose we do the same thing for uh, a rotation of an object like this cube in 3 space, where the rotation takes the cube and turns it in some way. In fact, suppose we rotate, say, by an angle theta around the E3 axis, which, as usual, I'm thinking is coming out of the board at you. So sometimes in physics classes, an arrow coming at you is indicated by putting a little circle around the dot. And so here's E3 coming at you. So again, the easy way to work out what the columns of such a matrix are is just to look where E1, E2, and E3 go. And as we saw before, E1 goes to some combination. I'll write it this way this time. It goes to what? It goes to cosine theta E1 plus sine theta E2, which you can see from that picture. And E2 goes to minus sine theta E1 plus cosine theta E2. Okay, that's what you can see from that picture. And where does E3 go? Well, E3, if I'm rotating around the E3 axis, E3 goes to itself. Okay? So from that, we can work out what the matrix looks like. Well, the easiest one is the third column, because that's just 0, 0, 1, right? E3 and E3. The first column, well, looks exactly like the second, like what it did in 2 dimensions. It's just that there's no, I could write, plus 0 E3. So this guy is going to be a 0 down there. Similarly, there's no E3 here, so there's going to be a 0 down there. But it's cosine theta E1. So that means I have a cosine theta there, plus sine theta E2. And similarly, E2, the second column, indicated by where E2 goes to minus sine theta E1, that's that entry, plus cosine theta E2, 0, E3. So the matrix looks just like the matrix in 2 dimensions, except it's if you will, increased by adding an extra row and an extra column that corresponds to the vector E3. I mean, the fact that this extra row is really because my vectors now have an extra entry at the bottom, right? So if you didn't notice the change, there you have it. What about the analog of the quarter turns? Okay, so what about the quarter turns? The things I called J after John. Okay, so what are the analogs of that? Well, if I go around the E3 axis, maybe I'll call that one J3. Okay, well, that one, what's it going to do? Well, let's look at the picture first. I'll bring this up now. Okay, I don't know if you can see that, but I think I've made this. This is the cube expanded to twice its size. So the origin actually is sitting here. You can't quite get it into the board. Here's E3 sticking out at you. Here's E1 and here's E2. So I've magically moved the origin out to the middle here. And if I make a quarter turn, okay, the quarter turn again takes E1 to E2, takes E2 to minus E1, and it takes E3 to itself. So we can quickly write those down. Okay, since E1 goes to E2, I get that. That's reflecting E1 goes to E2. E2 went to minus E1, so And E3 again goes to E3 if I make a quarter turn around the E3 axis. That's what that subscript says. So this guy here is around the E3 axis. And I have that guy. Which of course is that substituting in theta equals pi over 2 if you want to do it that way. Okay. What about the other ones? Well, there's another quarter turn J2 and another one J1, where again the axis indicated by this is fixed, so that's going to have, say, E2 is fixed. So this is around the E2 axis. So I'll put in the column that's easy to do. I'll let you figure out the other ones. So the middle column is that, and the question is what goes there, 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 what goes there. And J1, well, E1 is fixed. This is around the E1 axis. And same questions for what goes in these spots. Okay, so in 3 dimensions, there are really 3 different quarter turns, and you might think about what happens as you go up to R4. How many different J's are there that take the, quarter turns that take sort of the corresponding cubic lattice to itself, and how about an Rn? How many are you going to get? Anyway, I thought you might have fun with that, and see you at the next Coronavirus University lectures.